lesson 11.3, areas of polygons, part 1. First one is area of a rhombus, and that formula is going to be 1/2 the diagonal, first diagonal times the second diagonal. Okay, so if you have a rhombus, that wasn't a very good drawing of one, but all 4 sides are the same, then the 2 diagonals should be, no. Okay, so we have from here to here is diagonal 1, so this line right here, from here to here is diagonal 2, right? Okay, so you just have to remember you're going to multiply the 2 diagonals and then divide it by 2. And area of a kite is actually the same formula, so that's nice not to have to memorize 2 different formulas. So the area equals diagonal 1 times diagonal 2. So if we have a kite, okay, we're gonna have diagonal 1, diagonal 2. So from here to here, diagonal 1, from here to here, diagonal 2, and you just plug those in. Okay, so let's look at an example. If you're given, let's look at something that looks like this. And you know these 2 are the same and those 2 sides are the same. Then you can say, oh, that's a kite, okay? And then they're gonna give, this is 15. This is 8, 8, and 3. Okay, so we know it's a kite, so its area is gonna be 1/2 diagonal 1 times diagonal 2, which means 1/2 15 plus 3, 8 plus 8, 1/2 of 18 times 16, or 144 square units. Okay, so not hard, just need to remember them. And I'm pretty sure we looked at the reference sheet and that will be on there, so that's a good thing. You just got to be able to recognize if it is, what type of shape it is. So if it's a rhombus or a kite, you're going to use the same formula. Just find the 2 diagonals. Be careful. This would be an example of one that they might put an X or an X plus 7 in there or whatever. So just watch what they have. You got to make sure it's the whole diagonal times the whole diagonal. Okay. On the back of this page, I want you to leave a space. I'm going to have a handout for you to tape in there, okay? All right, so in the diagram, ABCD, ABCDE is a regular polygon, and I need everybody to remember what regular polygon means. All the sides are the same, right? Regular polygon in circle F. Okay, so we have a polygon inscribed in the circle. And we are going to find each angle measure. Okay, now I need you to actually really pay attention to this one. Not that you don't, but these are the ones that you're gonna have to use a little bit of thought. So let's see, I'm gonna make C and then D, E, A, and then right here, B. Okay, so ABCD is a regular polygon. So because it's a regular polygon, we know all those sides are the same, right? Okay, we want to find the measure of angle AFE, the measure of angle AFG, and the measure of angle GAF. Okay, so where's the F? Here it is. F is going to be the middle of the circle, right? Because that was circle F. Okay, so if this is all they give you, I want you to think about a few things. If this is the center of the circle, then from F to E would be from the middle of the circle to the edge of the circle, right? So that means that's a radius. And wouldn't F to A also be a radius? Okay, so if that's true, those two sides have to be the same. So those are radii. Okay, and we're gonna name this right here G. If we first look at AFE, AFE, right, is a central angle. So let's put that in your notes. AFE is a central angle. Okay, what do we know about central angles? They're the same measure as the arc, right? But also we know that if it's a pentagon and it's a regular pentagon, then that central angle is going to be equal to a 360-degree circle, right? Divided by 5. So try to remember that, not try, you need to remember that, because they're gonna expect you to be able to find that central angle very easily. Okay, so AFE we found was 72 degrees. All right, now we need AFG. So we're gonna drop a line down. Now, here's a word that I need you to remember. Line segment FG is an apothem. That's the name of that. So if you have a polygon inscribed inside of a circle and you drop a line from the center to the edge of the polygon, not the edge of the circle, but the edge of the polygon, that's called an apothem, okay? Because those two sides of that triangle are both radii and they're equal, when we drop that line, it bisects. So FG is an apothem and FG bisects angle, well, line AE and angle AFE. So not only does it bisect that bottom, it also bisects that angle up at the top. So angle AFG, which is what we wanted to know, is going to be equal, AFG, up half of the whole thing, that whole central angle, so half of 72. Okay, so AFG has to be 36 degrees. And you're going to want to remember that, because what did we just create when we dropped that apothem down? We created a right triangle. So now you can figure out what that angle is, AFG or EFG, either one. so that you can use the trig functions in that right triangle to figure out the other angle or one of the sides, whatever you need. Okay, and then lastly, we need the measure of angle GAF. GAF. So what could we do? Well, we know that all the angles in a triangle add up to 180, right? Okay, we just said that this angle is 90 degrees. We figured out that this angle is 36 degrees. So we can do 180 minus 90 minus 36. So GAF is going to be 54 degrees. Okay, all right, that's it.